just press that button.
You got it.
So. Just press it on. Sure.
The committee will come to order.
Without objection, the chair is authorized to declare recesses of the committee at any time. Welcome to today's hearing entitled Advanced Air Mobility, the Future of Unmanned Aircraft Systems and Beyond. I'd like to now recognize myself for 5 minutes for an opening statement. I want to say thank you to all you folks for being here. We appreciate the witnesses. Today's hearing will examine research and development of advanced air mobility, also known as AAM, and unmanned aircraft systems, also known as UAS and commonly called drones. The hearing will also provide an overview of how advanced R&D can enable supply chain security and safe integration of UAS into the national airspace system. There are two challenges for the deployment of next-generation autonomous systems across the country: the need for more research and development and an improved regulatory framework. The Science Committee has jurisdiction over federal research and development, so that will be the focus of our discussion today. Additionally, the hearing will also serve as a legislative hearing for the National Drone and Advanced Air Mobility Initiative Act, a bill to improve research, development, deployment, and manufacturing of UAS in the United States. As the name suggests, UAS are complex systems made up not only of the aircraft, but also of the supporting ground, air, and communications infrastructure. Advanced Air Mobility, or AAM, integrates new technologies to enable urban and inter-city movement of people and cargo delivery. It can be either manned or unmanned. Commercial use of UAS and AAM have the potential to carry out a wide range of missions across a broad range of sectors, including agriculture, weather monitoring, critical infrastructure, transportation, public safety, and disaster relief, which can greatly benefit our society. UAS experimentation and testing at high schools and universities might also lead to technology breakthroughs, as well as inspire students to enter the STEM studies. However, due to the delays in integrating UAS into the national airspace system, these technologies are unable to reach their maximum potential. As a result, U.S. companies are going overseas to conduct UAS R&D, which directly impacts our national security and economic competitiveness. Our goal today is to better understand the research underway to overcome these barriers and how we can streamline UAS and AAM integration. We cannot afford to delay much longer. The Chinese Communist Party has made it clear that it wants to dominate the globe in key technology areas, and drones are certainly one of them. One CCP-supported Chinese drone company has a near monopoly of the drone market, providing 90% of the drones used for public safety operations in the United States. That means that our police, our first responders, and even border agents are using hardware and software from a company that is tied to the CCP, which should have everyone here very concerned. Relying on these drones from China is putting our privacy and our security at grave risk. And we're also losing out on the economic benefits of having American businesses compete in this rapidly growing industry. UAS also hold great potential for assisting civil agencies. NASA, NOAA use UAS to conduct research, and Customs and Border Patrol use UAS to monitor the border and track smugglers and cartels and those who have crossed the border illegally. In addition to the benefits, it is critical that we carry out R&D to better understand how to mitigate the public safety challenges posed by UAS. As the United States faces growing competition from the CCP and other adversaries, it's never been more important to maximize our federal R&D resources. The federal government has a long tradition of investing in fundamental research and having the ability to understand, control, and manufacture materials that will be essential to our success in domestically producing these drones. I want to thank all of our witnesses for taking the time to participate in today's important hearing. Your expertise will be invaluable as we continue to look at the future of unmanned aircraft systems advanced air mobility, and the competitiveness of the United States. Before I recognize Ranking Member Lofgren, I want to yield just a minute more to myself to recognize some very special folks in our audience. We have several individuals from the 147th Attack Wing, based out of Ellington Field Joint Reserve Base, which is in my district, the 36th Texas. The significance of their presence here in today's hearing is that the main mission of the wing is the operation of their MQ-9 Reapers. In fact, one of the individuals here today, Major Carl McGarvey, is a Reaper pilot. Others here, raise your hand, Major. Yes, sir. Others here include Chief Master Sergeant Brant Spinrath, his wife Amy, Senior Master Sergeant Jason Howard, and Technical Sergeant Stacy Sanchez. All play critical roles in the support and operation of the MQ-9 mission. I'm very, very proud of each of you and very honored to have you up here in Washington and coming by my office and visiting and sitting in on this hearing. So with that, I'd like to recognize Ranking Member Lofgren for her opening statement.
Well, good morning, and I want to thank Chairman Lucas for this hearing, and also thank Chairman Babin for filling in for Mr. Lucas today. And I'd like to thank our expert witnesses for appearing before the committee. As I said in our Space and Aeronautics Subcommittee hearing just a couple of weeks ago, aviation is critical to this country's economy and global leadership. Aviation is also undergoing a transformation. Now, today's hearing focuses on a few transformative systems: uncrewed aircraft systems, also known as UAS or drones, and advanced air mobility, as the chairman has said, or AAM, and the role of federal R&D in advancing the use of these technologies. In 2018, in the FAA reauthorization, we directed R&D priorities to enable drone operations and integration into the national airspace system. Now, reviews and reports conclude that progress has been lagging. We need to understand why that is, and because significant economic and societal benefits are at stake. Now, both the UAS and AAM are projected to be multi-billion-dollar markets, including manufacturing and services. Unfortunately, the U.S. is not alone in recognizing the potential of this sector, and as some countries are actively integrating drones into their airspace, and as the chairman has said, others are dominating the drone manufacturing market. Expanded drone operations and eventual AAM deployment can improve wildland fire detections and response, a key issue for California and the rest of the United States. Deliver medical personnel and supplies to rural areas and disaster zones. And I'll point out that a large part of my district is underwater as we speak here today. Expand our environmental monitoring, conduct safer industrial inspections, and a lot more. Federal R&D investments can and should address these applications. That's why I'm so pleased to have Dr. Kopardekar, and you'll help me if I'm mispronouncing your name, here today. He is a wonderful public servant and NASA's expert in the integration and management of next-gen air vehicles into the national airspace system. In fact, he is the inventor and patent holder of the NASA UAS Traffic Management System, or UTM, which makes it possible for small drones to safely conduct complex operations in the national airspace system, which NASA developed and delivered to the FAA in 2020. Now, of course, I want to also highlight that he's based at NASA Ames Research Center, which is just a stone's throw away from my district in California. Ames has been leading an innovative effort that applies the UTM system to real-world emergency response operations, and particularly the integration of drones in wildland detection, and particularly the response, the mitigation, the detection of the same. It's clear that the American public, businesses, and workers stand much to gain from the utilization and innovation of UAS and AAM tech and their safe integration into the airspace system. We need to understand and mitigate potential risks associated with that. Today's hearing is an important step in gaining that insight, and I look forward to hearing from our witnesses what's needed to support the maturation and operation of a safe, effective, and innovative civil and commercial drone system, how research and development, including counter-UAS technologies, can identify and help mitigate potential risks. And I'd like to thank you, Mr. Chairman. Before I yield back, I'd like unanimous consent to put in the record a letter from the Transport Workers Union of America.
Without objection, so ordered.
And with that, Mr. Chairman, I am looking forward to seeing how this technology can help mitigate potential risks, and including those related to safety. There's privacy issues, security issues, emissions, noise, and the rest. And I yield back.
Yes, ma'am. Thank you, Ms. Lofgren. Appreciate it. And also, I neglected to say, but our full chairman is unable to be here today. As you probably noticed, I'm not 6'6" like he is. Big guy from Oklahoma. We miss him. He had a funeral and family of a family member, so we'll keep him in our prayers as well. So let me introduce our witnesses. Our first witness today is Dr. Jamie Jacob, who serves as the Williams Chair in Energy Technology and Professor of Aerospace Engineering at Oklahoma State University. He is also the Executive Director of the Oklahoma Aerospace Institute for Research and Education and the Director of the Unmanned Systems Research Institute at OSU. He also serves as the Vice Chair of the Oklahoma Governor's Council on Aerospace and Autonomous Systems, and previously served as a member of the Governor's UAS Council. Thank you for being here. And our next witness is also, as Ms. Lofgren mentioned, Dr. Parimal Koperdecker. Is that right? Koperdecker, okay. I think he's better known as Dr. PK, the Director of NASA Aeronautics Research Institute and a Senior Leader of the NASA Aeronautics Research Mission Directorate. He previously served as the NASA Senior Technologist for Air Transportation Systems and as the Manager of NASA's Safe Autonomous Systems Operations Project. Dr. PK also chairs the International Civil Aviation Organization's Unmanned Aircraft System Advisory Group. Thank you for being here. Our next witness is Ms. Lisa Ellman, co-founder and executive director of the Commercial Drone Alliance. She is also a partner at the law firm of Hogan Lovells and serves as the chair of the firm's uncrewed aircraft systems practice. Ms. Ellman also serves on the NASA Advisory Council Aeronautics Committee, as well as the FAA Beyond Visual Line of Sight Rulemaking Committee. She has held a variety of positions at the White House, at the DOJ, including leading the DOJ's effort to develop policy to govern the use of UAS in the United States. Thank you for being here. And our final witness is Mr. Sean Casey, the Chief Research and Development Engineer for Airwise Solutions. He is also an adjunct professor for system safety and reliability analysis for the Oklahoma State University Institute for Technology at Tinker Air Force Base. We have a couple of Oklahomans here, so that's good. Mr. Casey has also served as a principal investigator and program manager on several unclassified DoD, UAS, and AAM programs. I want to thank you all for joining us today. And so now I would like to recognize Dr. Jacob for 5 minutes to present his testimony. Dr. Jacobs.
Thank you very much. Chairman Babin and Ranking Member Lofgren and distinguished members of the committee, thank you for inviting me to testify today. It is an honor to speak with you about the work we are doing within the state of Oklahoma and across the U.S. to advance emerging technology in the U.S. and advanced air mobility and safe integration in the national airspace. I can only share with you a sample of what we are doing today. Since development of laboratories for autonomous and remotely piloted aircraft in the 90s for undergraduate teaching tools, Oklahoma State University has been a leader in aerial robotics. As part of our land grant mission, we have fostered education, research, outreach, and application of these systems into areas of public use, such as agriculture, energy, environmental monitoring, and national defense, working with national labs and industries alike. We have used this technology to help spur interest in aerospace and other STEM careers, particularly for K through 12 outreach, underrepresented minorities, including urban areas and tribal nations, leveraging programs within the Choctaw, Cherokee, and Osage nations of Oklahoma, providing new opportunities for these sovereign nations to use this technology to support their tribal members and develop new entrepreneurial activities within their borders and support their federal customers. Of critical national importance is OSU's Counter-UAS Center of Excellence. Supporting the needs of both the Departments of Defense and Homeland Security, the Counter-UAS Center of Excellence works with private companies to evaluate threats of drones by state and non-state actors using the systems as both symmetric and asymmetric weapons threatening U.S. warfighters and the public, as well as evaluating systems to detect, identify, and mitigate these threats. In addition to developing the gold standards to evaluate these defensive systems, the Counter-UAS Center of Excellence is currently working with the U.S. Army to develop curriculum and training capabilities for the DoD Joint Counter-UAS University to train soldiers in counter-UAS technology across all branches of the military and help bridge the gap in knowledge. Federal support has been the catalyst to enable this use-inspired research. Government funding has been a powerful driver in pushing technology from the laboratories to end-user adoption, crossing the valley of death that many innovations never bridge. Support from programs such as the NASA University Leadership Initiative, National Science Foundation National Robotics Initiative, and projects with the FAA has allowed us and other universities to push the boundaries in using UAS to improve aviation weather observations and forecasting, which will result in adoption of AAM solutions in urban settings and greatly increase our capability to accurately forecast weather in disasters such as wildfires, floods, tornadoes, hurricanes, saving lives and property. As an example of this, through EDA funding and cooperation with private and tribal partners, we have launched the Launchpad AAM Center of Excellence flight range within the Osage Nation and Tulsa Innovation Laboratories to develop novel programs to support small business innovation and provide unique flight testing solutions, helping to bridge this divide. Facilities such as the Choctaw Nation of Oklahoma test site as part of the FAA Beyond programs are critical to U.S. capabilities. Further development and funding of these sites and other facilities that allow testing of this technology to evaluate use cases and performance is much needed to provide crucial safety data for the FAA, such as advancing beyond visual line of sight drone operations and routine cargo deliveries of critical supplies for first responders, disaster response, medical emergencies, and impoverished regions. I believe we're in a new golden age of aviation with the introduction of new technology, in this case autonomy and electrification, that will have a tremendous impact on the U.S. and how individuals use aerial transportation for travel and commerce. This era that we are in the process of birthing will have an even wider reach than the two that went before. We believe the future of advanced aviation is bright and that the quality of life for all Americans can be enhanced by advancing and exploiting this emerging technology. Research conducted at land-grant and other universities through public-private partnerships play a critical role in this potential prosperity, but we need the federal government's support to ensure that these technologies flourish and provide the benefits to all Americans that we know are possible. Thank you again for inviting me to share my opinions. I will be happy to answer any questions that you have. I appreciate the support the committee has provided for U.S. research activities throughout its work. And I'd like to wish Chairman Babin a happy birthday.
Thank you very much, Dr. Jacob. I appreciate that. Thank you for being here, too. I now recognize Dr. P.K. for 5 minutes to present his testimony.
Thank you, Chairman Dr. Babin, and happy birthday. Ranking Member Lofgren and distinguished members of the committee. I want to thank you for the opportunity to speak to you about the future of unmanned aircraft systems, UAS, and advanced air mobility, AAM. My name is Parimal Kopardekar. I am the director of NASA Aeronautics Research Institute, and I am located at the agency's Ames Research Center in the Silicon Valley. A major global aviation transformation is beginning, and we must innovate in aviation while maintaining its safety tradition. NASA is collaborating with government agencies, academia, and industry to develop UAS and AAM technologies that will provide many societal benefits. Small UAS are now being used for applications such as agriculture and infrastructure inspection, cargo delivery, and emergency responses. Transformative aircraft design is enabling advanced air mobility, a market likely to reach $150 billion annually with 280,000 domestic jobs by 2035. NASA invests in aeronautics research to address the most critical pressing challenges by developing and transferring key technologies to the FAA and industry. In the past, NASA has transitioned several U.S.-related technologies. We developed Unmanned Aircraft System Traffic Management, referred to as UTM. NASA had 85 industrial partners, including many startups that are now market leaders. The UTM will safely enable high-scale operations of smaller drones in low-altitude airspace. For advanced air mobility, in collaboration with FAA and industry, we are researching topics such as airspace integration, aircraft noise, safety, and community acceptance. Over the next several years, we will conduct demonstrations called national campaigns to examine how the entire AAM system will work. NASA is leveraging the Small Business Innovative Research Program to advance US and AAM. The agency has given multiple grants through University Leadership Initiative, one of them is him, Minority University Research and Education Program to build the next generation workforce. NASA is working with Department of Defense's Agility Prime to analyze AAM supply chain needs, gaps, and opportunities to grow the U.S. domestic manufacturing sector. In short, NASA Aeronautics has committed significant resources to ensure that UAS and AAM concepts and technologies will mature, scale, and be safely operationalized. U.S. leadership in this sector cannot be taken for granted, as other countries are closely following our progress and seeking to surpass us. The AAM Leadership and Coordination Act, which was enacted last year, will further strengthen our collaboration with FAA and the other agencies. Additionally, NASA is an active member of the Department of Transportation's recently formed Advanced Air Mobility Interagency Working Group consisting of 19 federal agencies. As you are aware, there has been a surge in large wildfires across many states, including California. Top 5 fires of 2021 costed over $1.7 billion, and each lasted for more than 1 month. NASA is researching how UAS and AAM capabilities can be applied to the challenge of wildland fire. We successfully demonstrated initial capabilities with the United States Forest Service and CAL FIRE. NASA plans to develop a portable UTM system to enable 24-hour aerial suppression by remotely operated UAS. As an agency, we will work together with other government agencies to develop a joint concept of operations to advance the state of the art. Thank you again for allowing me to address this committee. I would also like to thank this committee for its continued support of NASA aeronautics research, and I look forward to answering your questions.
Thank you, Dr. PK. Appreciate that. Now I'd like to recognize Ms. Ellman for 5 minutes to present her testimony.
Thank you. Chairman Babin, Ranking Member Lofgren, and distinguished members of the committee, thank you for the opportunity to share my thoughts with you at this important hearing on how we can safely integrate advanced aviation technologies into the national airspace system for the benefit of all Americans. My name is Lisa Ellman, and I am the Executive Director of the Commercial Drone Alliance and Chair of the Global Uncrewed Aircraft Systems Practice at Hogan Lovells Law Firm. The CDA is an independent nonprofit organization made up of leading entrepreneurs and innovators in the industry. We work closely with the federal government to enable safe, secure, and timely drone integration. I am honored to provide remarks to inform your consideration of how the United States can enhance our role as a global leader in advanced aviation, including through research and development. The commercial drone industry is delivering significant, life-saving societal and economic benefits for all Americans. As just a few examples, drones are fighting wildfires, responding to disasters, including recent train derailments, and enhancing public safety. Drones are enhancing worker safety as well. In 2020, there were 54 accidents resulting in 13 deaths in the aerial agricultural industry, including in many states represented by this committee. Use of drones for these operations can prevent such fatalities. Drones are democratizing aviation by opening the industry to a broader workforce, creating jobs, and boosting our economy. Drones are promoting infrastructure resilience, providing early detection of oil and gas leaks, and inspecting our nation's railways, bridges, and electrical grid. Drones are expanding access to medicines and critical supplies, including for vulnerable populations. Drones are enhancing sustainability and reducing carbon emissions associated with traditional transportation methods. Advancing this industry will ensure America's global competitiveness, our national security, and our leadership in global aviation. But these benefits cannot yet be truly realized here in the United States because regulatory paralysis has limited the integration of UAS into the national airspace. Congress led the way in 2012 by mandating UAS integration. In the decades since, that mandate remains unfulfilled, as drones are often subject to application of incongruous regulations designed for crewed aircraft. Despite the best efforts of many, the FAA continues to view UAS integration as, in its own words, a long road ahead and a significant challenge. Meanwhile, America is falling behind other countries, both allies and competitors. In order to survive, many U.S. companies have had to pursue opportunities in international markets. This trend will only accelerate so long as the U.S. government fails to integrate UAS here at home. Bold and decisive congressional leadership is necessary once again to spur progress. Research and development has a critical role to play here. But research and development has been exceedingly difficult for U.S. companies under the current regulatory framework. To illustrate, consider that a U.S. company designing an uncrewed aircraft that weighs 55 pounds or more must currently wait years to begin conducting R&D on its own property due to lengthy approval processes. While innovative programs like Beyond and test sites try to offer alternative pathways, these programs are also often plagued by lengthy regulatory approval processing times. Congress can fix these challenges. The CDA commends the co-sponsors of the National Drone and Advanced Air Mobility Initiative Act for your commitment to accelerate the deployment of these beneficial technologies. There is much good in the bill. In line with the spirit and intent of the legislation, we have several ideas to improve it. I will highlight just a few of them here. First, we urge Congress to focus on leveraging existing resources, such as Assure, the Beyond program, and UAS test sites, and enable these programs to actually function as they were meant to, as proving grounds for innovation. Second, R&D priorities should focus on validating future UAS capabilities in complex airspace. Third, Congress should take additional measures to support the growth of UAS and AAM manufacturing capabilities in the United States. And finally, Congress should support the integration of counter-drone technologies into complex civil environments, including around busy airports and at mass gathering events. The absence of a viable UAS regulatory framework continues to be the most significant barrier to integration, and a robust R&D program will only succeed if accompanied by a reasonable regulatory environment. The CDA appreciates the opportunity to appear before you. We look forward to continuing to collaborate with you to ensure America's global leadership in advanced aviation. Thank you.
Thank you very much, Ms. Ellman. I'd like to now recognize Mr. Casey for 5 minutes to present his testimony.
Thank you, sir.
Yes, sir.
Honorable Chairman Babin, Honorable Committee, Ranking Member Lofgren, and esteemed members of the U.S. House Science, Space, and Technology Committee. Without any undue exaggeration, this is a Sputnik moment. The Chinese High-Altitude Balloon, or HAB, or Uncrewed High-Altitude System, UHS, this term chosen purposefully as this is actually a drone by definition and capability set, or UHS incursions directly over U.S. continental motherland home space this late January to early February of 2023, are historically only rivaled in audacity or encroachment by the USSR's Soviet Sputnik programs of 1957 and beyond. The wake of such early Cold War events and Sputnik-era technology being flown directly over continental U.S. airspace in 1957 led to an exasperated U.S. public, which in turn led to the establishment of the Select Committee on Astronautics and Space Exploration in 1958, which today is this very committee, the U.S. Science, Space, and Technology Committee, I'm honored to speak before. It is important to note we are no longer in a Cold War to establish the most elite forms of the best technology in the world against the USSR, but rather a cool war to establish the most scalable forms of good to great technology. against the People's Republic of China and the ever-domineering Chinese Communist Party. The CCP has a published Beijing policy, such as the Xiaoshuanjin policy or strategy, which is also known as Assassin's Mace or Death by a Million Cuts. This seeks to use an array of affordable ballistic missiles, cyber attacks, and commercially produced or copied aerial UAS or AAM technologies to overwhelm U.S. air superiority by a basis of cost to defeat scenarios. Much like forcing the U.S. to spend millions of dollars to scramble multiple F-22 fifth-gen fighters, deploy several U-2 Lady Bird high-altitude reconnaissance planes, and deploy additional E-3 Sentry AWACS, and supporting RC-135 reconnaissance aircraft, then to further spend potentially several million more in ground-based radar support and advanced real-time satellite imagery, to ultimately fire a $399,000 ballistic missile, the AIM-9X, to pop a UHS or balloon. Today, I testify representing Airwise Solutions, a mid-scale UAS startup. Airwise Solutions Incorporated is uniquely a U.S.-based uncrewed aerial system hardware and software manufacturer with academia backgrounds that exist in the jurisdictions of Oklahoma, Tribal Nation, and hub zone allocated lands. We believe that American small business fully encapsulate the actual need for U.S. manufacturer development and the entrepreneurial spirit of the proposed bill. It is unquestionable this bill will be transformative for the U.S.-based UAS manufacturing industrial base, and as such, we are honored to offer our congressional testimony and support for the concept of the National Drone Advanced Air Mobility Initiative Act. I previously had the privilege of serving in Department of Defense counter-UAS capacities as an active participant in a multi-year tri-service advanced autonomous platform activity. When the original concerns of covert foreign nation data security breaches in turn triggered the sanctions of Section 848 of the NDAA for fiscal year 2020. Since January of 2021, I have served as a chief research and development engineer for the largest Oklahoma origin UAS manufacturer. Now on the opposite side of counter-UAS development in the world of US-based UAS development, I have the firsthand knowledge of the incredible strain U.S. industry has gone through to meet NDAA Section 848 compliance and or Defense Innovation Unit Blue List or Blue UAS compliance. With the passage of the original NDAA Section 848 sanctions, over an estimated 80% of the commercial U.S. market in the U.S., with DJI, again, a single China origin vendor accounting for 76.1% of the market, was no longer immediately available for supporting federal acquisition of UAS. The effects of NDAA Section 848 were largely twofold. The United States government no longer maintained a strong industrial base to rapidly acquire even basic small UAS, and thus a critical supply chain issue exists. And B, U.S. industry largely did not compete with covert foreign nations, namely the People's Republic of China, for small UAS technology development, and was or is largely unprepared to match the United States government more advanced technology needs. Moreover, with the critical technology and developments in the ongoing Ukraine invasion, we have seen the emergence of the small UAS technology becoming a force multiplier with a critical supply chain that few analysts could have predicted in the 21st century battlefield. It is important to note that the same small UAS technology emerging in the recent military events is the same technology that is really driving a profound renaissance in our industry. From multispectral cameras in agriculture to methane detection, oil and natural gas safety to photogrammetry technology and survey-grade construction, for infrastructure to ozone detection and environmental protection, and even last-mile delivery for medical devices or equipment. To direct science and technology applications ranging from collecting whale snot or marine data via UAS, monitoring global greenhouse gases via UAS, and even to flying into active Category 4 hurricanes for atmospheric monitoring data via UAS. However, currently the NDAA Section 848 has actually kind of put the United States government in a position where we only have 15 approved platforms you, as the government, can actually purchase. The U.S. UAS industry has a strong history of hobbyists, tinkers, and garage shops, but ultimately it's going to be up to this committee to accelerate them into a commercial industry. It's going to be up to this actual bill and this actual industry involvement this committee is focused on to actually catch up globally and further be a U.S. technology global leader, as is the American way. Thank you for your time.
Yes, sir. Thank you very much. I thank all the witnesses for your testimony, and we're looking forward to hearing some of your expertise for our questions. So the chair would like to recognize himself for 5 minutes, and I'll start with Dr. P.K. Your testimony indicates that NASA is working with the Department of Defense's Agility Prime to analyze AAM supply chain needs, gaps, and opportunities for the U.S. manufacturing sector to grow. Can you elaborate on what this entails? As we've heard from multiple sources, UAS supply chains are particularly vulnerable to foreign exploitation as a result of offshoring, design, manufacturing, and R&D.
Chairman, very important question for U.S. competitiveness and domestic jobs in manufacturing. If you look at the conventional aerospace and defense, there are about 50% jobs are in supply chain, and over 50% revenue comes from supply chain. So it's really critical that we maintain that competency in the United States. As a result, DoD and NASA, we started a joint working group as the industry related to advanced air mobility was just kicking off. The idea of this working group is to educate the advanced air mobility new entrants about the need for setting up supply chains early on, as well as building awareness for small and medium-sized enterprises about the opportunities that advanced air mobility is going to bring for manufacturing. So the goal is to try to promote the gaps that exist today and say that here are the opportunities for small and medium enterprises to launch businesses related to manufacturing and supply chain in the aerospace and defense world, particularly advanced air mobility. And we continue to do this work in collaboration with the DoD's Agility Prime. We share everyone our lessons learned from the previous experiences in what happened with the drones, as well as commercial aerospace and defense, and importance of building resilient supply chains. So ultimately, we would like to understand all the needs, identify the gaps and opportunities so that our domestic manufacturing sector can continue to grow.
Thank you very much. I've got one more for you, Dr. PK, and if I've got time, I'm going to go to Ms. Hellman. As I mentioned, Dr. PK, at the beginning of this hearing, I have a unique interest in MQ-9 Reaper operations within our national airspace system. In 2018, as part of the UAS-NAS research project, NASA flew an unmanned aircraft in the NAS without a chase plane. What is preventing the integration of our nation's remotely piloted aircraft into the NAS, whether for civil or military application? No, this is for
For me,
Dr.
okay, yeah.
PK. Sorry.
Thank you again, Chairman, for this very insightful question, by the way. That NASA uses RQ-4 planes already for monitoring the launches and collect data in real time about the health and status monitoring of the launch systems. In terms of the MQ-9, I'm really delighted to see the MQ-9 team was here. I kind
There
of,
you go.
the MQ-9s, some MQ-9s that we collaborated with have detect and avoid systems, and once you have detect and avoid, then you don't need the chase. But if you don't have detect and avoid on board or on the ground-based detect and avoid to maintain the safety of the overall operation, then you would need a chase core. Now, NASA has done fundamental research on the detect and avoid technologies to set the minimum operating performance standards, and that technology has resulted into a standard, so which we are very happy about. We definitely plan to continue the research to streamline the process and work with FAA and others to ensure that we have detect and avoid technologies for these emerging autonomous aircraft operations.
Okay, thank you very much. Ms. Ellman, your testimony describes a lengthy, burdensome, and bureaucratic process for conducting UAS R&D, and you conclude by stating that a U.S. company must wait years to even begin conducting R&D activities, notwithstanding the fact that the vast majority of these operations occur over private property at low altitudes and in low-risk rural environments. The Flight R&D Act, the last piece of legislation this committee produced in preparation for the last FAA reauthorization, would have granted exceptions for conducting R&D below 400 feet in Class G airspace, 5 miles away from airports and on a non-interference basis with crewed aircraft. Unfortunately, this provision was dropped in the final FAA reauthorization. While exemptions for recreational UAS use exist, conducting UAS R&D would not qualify because it is conducted for purposes beyond, quote, personal enjoyment. So how can Congress refine this provision to accelerate domestic UAS R&D and preserve American competitiveness as an attractive location to conduct UAS R&D?
Well, thank you, Chairman, for this very important question, and thank you for your leadership on this very important topic. As I did note in our testimony, it is a very burdensome process for a company to be able to do R&D here in the United States, including at their own private property. And this has become a big, large impediment for U.S. companies looking to refine and develop technology here in the United States. This is particularly true if you're operating outside the Part 107 framework, so essentially companies developing vehicles 55 pounds and heavier. So I think, we would be, it's clear that the status quo is broken. I know that there are other efforts out there like test sites and the Beyond program that are trying to provide some paths forward, but even they have some lengthy approval processes. And, from our perspective, Congress can fix this issue. I think there are a number of ways that are possible to do it. We'd be happy to work with you on your proposal. Refining the airspace in which your proposal would enable R&D activity is one potential way of doing it. For example, limiting this activity to test sites or the Beyond program, for example. But another idea is to look directly at these approval processes and simply right-size them and not actually require a rulemaking every time a company wants to be able to do research and development here in the United States, which is a lengthy, burdensome process that does, much of it does not actually relate to safety in any way. So we would be very happy to work with you on that particular legislation, and thank you for your leadership on this important topic.
Thank you very much. My time has expired, so I now recognize Ms. Lofgren for her 5 minutes.
Thank you very much, Mr. Chairman. I want to return to the issue of wildfires in California. Right now, large parts of the state are underwater because of the floods. And because of that, when the floods go away, we're going to have an explosion of vegetation that will pose a fire risk. So we'll have both the floods and fires this year. I've been intrigued by NASA Ames' efforts to try and bring technology to the area of fighting wildfires. Now, I understand that most of these technologies, or a lot of them, have been developed at Ames. Could you expand on the portable UTM system you mentioned? What does it entail? How would it be deployed? What would it do?
Thank you. Thank you, Congresswoman, for asking this very important question. I just checked today, there are 10 large fires going on in this country across 3 states. So the fires are happening everywhere. And large fire, by the way, is defined as 300 acres or more. In 2021 alone, the top 5 fires costed over $1.7 billion, and each lasted for more than 1 month. And the men and women fighting these fires do an incredible job, but we can give them better tools. And if you look at how the current aerial suppression efforts occur, there is an air boss that is flying in an aircraft, watching outside the window for the helicopters and fixed-wing aircraft that are flying underneath, that are dropping water and retardant. As a result, it's all eyeball traffic management. So when the smokestacks show up or the visibility goes down, they stop the operations. So effectively, they fight fires through aerial means about 6 to 8 hours a day. You can imagine if we continue the firefighting to 24 hours a day, how much impact we can generate and how quickly we can extinguish these fires. So the goal of using drones and drone traffic management, or UAS and US traffic management, UTM, is to create a second shift environment where you can continue the operations under low visibility conditions by remotely operating these drones outfitted with water and retardant capabilities and managed by UTM in a box that is basically ensuring that the trajectories are deconflicted with each other and they're monitoring the trajectories for safe operations. And you can continue to fight these operations 24 hours. So that's sort of the idea of using advantages of UAS and UTM technologies. Additionally, the electric vertical and takeoff landing vehicles who can go and dispatch basically logistics equipment the night before when the firefighters go on the job in the morning. So we have opportunities to use these automated technologies to drop dispatch equipment, logistics support to basically reduce the burden that they have to carry with all the equipment. So a lot of opportunities exist. Also, one last example I'll offer you is the large drone, high altitude, long endurance drone can be outfitted with communication support equipment where the communications are not available when the wildfire fighting is happening. So really exciting opportunities, and I think NASA is taking charge of collaborating with industry as well as other government agencies to improve the state of the art.
Now, these plans would require heavier drones, and we're currently having, the FAA has been identified as a barrier. Are there other barriers that we need to address to get to what you've just described? Because this is critical for the state of California as well as other states.
Yeah, this is a very important capability and definitely going to change the game. Fortunately, wildland firefighting and aerial suppression happens during temporary flight restrictions, so the barriers are less to be able to try automated systems and automated technology because no one else flies in that airspace. So I think we get good FAA support. We have been collaborating with FAA on this concept.
Have they approved that yet?
We are collaborating. Right now, it's still in the basically conceptual and development phase.
Well, I thank you very much. You're right, our firefighters do a tremendous job, but we really need to allow them to have this force multiplier for their sake as well as the public. So thank you very much, Doctor.
Thank you very much. And now I'd like to introduce the representatives, Florida Space Coast, Mr. Posey.
Thank you very much, Chairman Babin. Dr. Pardikar, given your testimony and experience, besides our GPS system, what other navigation options is NASA looking at for unmanned aircraft systems and advanced air mobility?
It's a very important question, and really appreciate the support that we have in collaboration with Kennedy Space Center team. We have a number of options for alternatives to it's called APNT, Alternative Positioning, Navigation, and Timing Technologies, or GPS, so to speak. One of them is using low altitude, basically the satellite consortium, then using geo satellite consortium, as well as fiber optics related technologies. And another one that is currently being tested at a couple of NASA centers is using ground-based satellites or ground-based beacons to triangulate the positions. So not depending on the satellite-based GPS, but the ground-based system. So we have a number of opportunities when we are using SBIRs as well as some collaborative research with industry to figure out how will this be basically taken into account, right, to mitigate the effects of GPS degradation. We are also working with the FAA to understand what the requirements would be for advanced air mobility. This is also a critical component because if you want to operate in a vertiport in an urban airspace, you would need similar technologies to ensure foolproof navigation.
Thank you. Thank you very much. Ms. Ellman, you mentioned when talking about unmanned spacecraft systems or aircraft systems that American leadership is at risk. Would you care to elaborate a little bit?
Absolutely, and thank you so much, Representative, for the question. It's an important one. Here around the world, we've realized the benefits of this technology, and here in the United States, the technology has moved quickly ahead while the policies have somewhat lagged behind. And around the world, so companies have really struggled to be able to scale here in the United States, and that's because regulators and policymakers, there are lots of really great people working across the federal government, including at the FAA, trying to fit a square peg into a round hole, which doesn't fit, not surprisingly. They're trying to regulate UAS using incongruous regulations designed for crewed aircraft, and it's simply not working. And so we need broad regulations here in the United States in order to really open this industry up and bring these amazing benefits to the American people. Around the world, other countries and nations, jurisdictions, including, Australia, the EU, many other countries around the world are quickly moving forward, and frankly, many many companies here in the United States, U.S. companies, are having to go abroad in order to operate. There is a national security imperative. There is an economic imperative. We can bring so much money here to the United States, but it's also a national security issue if we do not have this, this industry cannot succeed here at home. And of course, we've heard a lot about China has their own plan focusing on the civil drone industry and becoming the global leader. And we need that same national vision, that same national plan here in the United States, and Congress can play a critical role here.
What should we do next to accomplish that?
Well, we have lots of ideas, and we'd be happy to work with you. I think in the short term, I mean, obviously R&D is critical. That's what we're here to talk about. But that said, you can't really unpair the R&D from the regulatory, because the regulatory enables R&D, or in this instance is getting in the way of R&D. So there does need to be attention to the regulatory issues, both to enable research and development here in the United States, as well as broad rulemakings, enabling expanded operations, enabling beyond visual line of sight, moving the, right now, the approvals here in the U.S. are very limited. Generally, first of all, if you want to fly beyond visual line of sight, in order to, bring these vast benefits to your community, you have to actually go through a very lengthy approval process, and the approval itself will likely be site-specific, geographic-specific, and incredibly limited.
We're talking FAA here?
Yes, we're talking the FAA here.
I can't imagine the FAA is dragging their feet and holding up progress.
There are a lot of great people at the FAA trying really hard, but it simply hasn't worked thus far. So, we appreciate, we do think Congress needs to lead here.
Thank you. Thank you very much. Mr. Chairman, my time's about to expire. I yield back.
Yes, sir. Thank you. And I'd like to recognize the gentlewoman from North Carolina, Ms. Ross.
Well, thank you very much, Mr. Chairman, and this is such an important hearing. Thank you so much to the panelists for being here to testify. I'm proud to represent North Carolina's 2nd Congressional District, and our state's Department of Transportation is one of 8 lead participants in the FAA's Beyond program. The Beyond program is a 4-year program following the former FAA Integration Pilot Program that aims to achieve economically viable, scalable, and repeatable beyond visual line of sight uncrewed aircraft system flight operations. I said that. All in one. NCDOT has conducted over 21,000 flight operations, which exceeds the number of flights conducted in total under the FAA IPP program among all lead participants. There has also been critical work done to enhance the delivery of medical supplies, as well as install low-altitude weather radars across the state. The work of NCDOT with its Beyond program illustrates the great strides that are being made in North Carolina to advance UAS integration. But as you've said, so much more can be done. I know, Ms. Ellman, you've been asked a lot of questions, but I'm going to start with you and then I'll move on. It's my understanding that the FAA has 7 designated test sites around the country to enable both private sector firms and public entities to test complex drone operations and conduct research and drone technology. How has the commercial drone industry benefited from these test sites?
Thank you, Representative, for that question, and thank you for your support of the great work that is happening in North Carolina. Many of our CDA members are working with the North Carolina DOT. They've been a fantastic partner, and it really kind of brings into focus one of the real benefits of the Beyond program is that we have been able to, in a limited way, bring some of these benefits to local communities, and of course, North Carolina was one area. The test sites as well have been critical partners for the FAA and critical partners for the commercial drone industry. That said, their effectiveness has been limited. They're trying to do a lot. They've gathered a decade's worth of data. It's unclear at this point kind of where all that data has gone since we haven't seen the rulemakings that we were hoping for. But they've also been limited by some of the the FAA's kind of interpretation, for example, of public aircraft operations. For the last several years, companies were able to work hand in hand with test sites to do research and development. And then over the last year or two, we've been essentially told by the FAA that, no, you can't, that, they've changed their interpretation, or in any case, that they have this reading of the law that prevents test sites or any public entity, including public universities or other public agencies, to collaborate with private industry under the aeronautical research prong of research and development that's traditionally regulated.
Oh, okay, I want to move on, actually, on that issue to Dr. Jacob.
Yep.
And Dr. Jacob, could you talk a little bit about universities' use of these test sites and the collaboration that Ms. Ellman was discussing?
And thank you, Congresswoman Ross, for that question. Again, I'd like to reiterate that North Carolina has been doing really great work and has been a fantastic example of what you can accomplish with the Beyond program. These access to the Beyond program capabilities has been very transformational for university research, in that we can work with these local test sites to be able to push the limits of what we're developing in the laboratory. So this has been very impactful for what we've been able to do. But like Ms. Ellman said, there are limitations in terms of the approval process in getting access to the airspace to really push the limits of aviation technology. If you think about traditionally what we would do with a manned aircraft, for example, that process is not dissimilar to what you would have with a uncrewed aerial vehicle, but you have to jump through extra hoops to be able to get that robotic aircraft in the air and tested, even at the test sites. And in particular, since the test sites tend to be self-funded, they have to, primarily resource assets and access to personnel through other non-traditional means.
And could you just briefly elaborate on the disincentives for collaboration that Ms. Ellman discussed?
Well, we still have to go through the same processes in terms of getting flight approvals. There's just extra access at the FAA level to be able to provide expertise to help assist the Beyond program members in achieving those permissions.
Okay, thank you, Mr. Chairman. I yield back.
Yes, ma'am. And I'd like to recognize a gentlewoman from New York, Ms. Tenney.
Thank you so much, Chairman Lucas and Acting Chair Dr. Babin, and happy birthday. And also to Ranking Member Lofgren for holding this hearing. And thank you for all the witnesses for your time and your expertise on this really important issue. And increasingly, these unmanned aerial systems are used by our law enforcement, Border Patrol, and military to carry out our critical homeland and national security operations. As every American knows, we currently have a crisis at the southern border, and UAS technologies can be a critical resource for the Border Patrol agents in addressing the crisis. This also plays a pivotal role in keeping our service members out of harm's way. Thank you to the gentlemen who were here earlier for serving our nation so honorably. But while UAS are used in a number of amazing ways, they're also being leveraged by criminals and our adversaries. And I'm honored to represent New York's 24th Congressional District, which includes a large section of our northern border in upstate New York. And if anyone's ever been there, the spectacularly beautiful area north of Clayton all the way to Lockport, including all the Finger Lakes. And I just recently spent an entire day with the Customs and Border agents from the Buffalo border sector, which borders onto the Swanton sector, which is where we're seeing this massive increase in immigrants. And they were describing to me how these drug runners are using UAS drones to enhance their drug trafficking efforts at the U.S.-Canadian border. Additionally, our nation watched as the Chinese flew a UAS sky balloon over our country for a week before President Biden finally decided to act on taking down the spy craft. So as such, we need to make further investments in this counter-UAS technology and to help counteract this malign use of these UAS technologies, particularly when you see the interaction with the border agents. But with proper investment, we can help our law enforcement, military, border agents in doing some of the great things that you guys are all researching and talking about. But I want to first ask Mr. Jacob, in your testimony and your role as Director of Counter UAS Center of Excellence at Oklahoma State University, great Oklahoma State, but as you may be aware, the current Secretary of Homeland Security must individually authorize each border sector to perform counter unmanned aerial systems operations. This is a major issue in the Buffalo border sector, where it took 3 weeks for Secretary Mayorkas to authorize this CUAS operation. Do you believe that these counter UAS systems should be used by the Customs and Border Patrol across the border, including the southern border, I might add, as they're being used now, or hopefully to be used soon?
Well, I do think that this technology will provide a great asset for border protection and monitoring. As you mentioned, Congresswoman Tenney, this is a serious problem, not only for incursions across the border, but potential use of commercial UAS to transport illicit materials such as drugs across the border. One of the problems that federal agencies have is the limited capability or access to assets, which are commonly called, blue UAS systems within the U.S. that have been approved for not only manufacturer but also vendors to provide capabilities in purchasing for federal agencies to utilize these systems within the national airspace. As was mentioned by Chairman Babin earlier, the predominant manufacturer of UAS across the world are Chinese, which then does limit our capability to use these systems within the national borders.
So you think you definitely support U.S. investment and continued investment, and you don't think it's sufficient?
I would agree with that statement.
Okay.
Yes.
Can you discuss maybe some of this, the counter UAS systems for 21st century combat and military readiness also, and where we are in terms of investment in that area?
Yeah, it's a great question, Congresswoman Tenney. This is an area where 10 years ago, the United States essentially ruled the skies. And it was only through, the advent of commercial systems which are readily purchasable by non-state actors such as ISIS, and allowed these systems to be used against U.S. personnel overseas, that we realized that we were falling behind. Primarily in terms of being able to develop systems that will not only detect and identify these, but determine a way to defeat them. This goes back to some of the concerns we raised earlier in providing access to test sites, which not only requires FAA approval, but also approval from other federal agencies, such as the FCC for spectrum management.
I want to reclaim my time just one second.
please go
I want to ask Ms. Ellman, in your testimony you said that 70-80% of the unmanned aerial systems market is controlled by non-U.S. companies. Can you just tell us briefly, if Mr. Chairman will allow a couple extra seconds, how we can increase manufacturing, especially as China uses these UAS systems for malicious purposes?
Absolutely. Thanks for that question. And on the counter UAS challenges, I just want to mention for a minute, because there are lots of legal challenges. It is a national security imperative that we enable our counter UAS companies to test and do research and development here in the United States. The Peters legislation, the Safeguarding the Homeland Act from last year, hopefully we'll see again this year, but that would actually create a pilot program to enable states, localities, and private sector entities to actually do R&D. Right now, as you noted, it's been limited to just a few federal agencies with very, very lengthy approval times, even within those federal agencies, to get approval to use the technology. On manufacturing, we absolutely agree. It's very important to bolster the domestic manufacturing industrial base here in the United States. We think the best way to do that is by opening up the regulations to allow this activity. Right now, it's very difficult for U.S. companies to succeed, but there are other direct and indirect funding ways to bolster the industrial base, and we would be happy to work with you on that.
Thank you. I appreciate all the witnesses. My time has expired, but I just want to say we've been trying to do this. My former colleague, John Katko, and I up in Syracuse area, we've been trying to develop this region. We're ideal location in upstate New York. So thank you so much to all of you. And unfortunately, my time has expired, but really appreciate your insights. Thank you.
And New Air in Syracuse are doing great work on all of that.
Yes, absolutely. Thank you.
Thank you all. I'd like to recognize the gentlewoman from Oregon, Ms. Salinas.
Thank you, Mr. Chairman, and happy birthday to you.
Thank you.
Thank you to our panelists. It's been a great conversation today. So, Ms. Ellman, in Oregon and across the West, so teeing off of my colleague from California's questions, the threats from wildfires are increasing every year as climate change leads to drier and hotter weather patterns and more natural disasters. And in Oregon, fire season lasts longer each year, and the costs of property damage, firefighting, disaster relief have skyrocketed as fires have become more severe. And in your testimony, you referenced, and again, we've talked a little bit about this, you've referenced the potential benefits of UAS to assist firefighting efforts in states like Oregon. Can you dig in a little bit more on what are the key research areas we need to focus on to improve effectiveness and actually accelerate the deployment of UAS technologies in disaster relief situations like wildfires?
Absolutely. Thank you, Representative, for that very important question. Obviously, disaster relief firefighting is a critical use case for UAS, including in Oregon and in other states. And I want to praise NASA and PK and all of the work that is being done on that topic. There is certainly more that can be done. From our perspective, additional research and development is necessary in order to enable complex UAS operations, including, in congested airspace. When there are wildfires, there could be helicopters as well in the future, AAM vehicles, essentially others in the airspace, and we need to be able to make sure that vehicles are all talking to each other, avoiding each other. You need to be able to fly over people. You need to be able to fly with heavy vehicles that can carry water and other materials. You need to be able to, what we would describe as expanded operations. And obviously, in a wildfire situation where there is a TFR in place, that's one thing. There's also the benefit of using drones for preventing wildfires in the first place. And while there are processes in place once the wildfire is started, there's a lot more that can be done on the front end to enable this technology to be used to prevent these wildfires in the first place. So I'd be happy to work with you and your office on that.
I would love that. Thank you. Dr. Kapardikar, thank you so much. You also mentioned wildfire fighting in your testimony, and you stressed the importance of interagency collaboration to ensure high standards of safety as UAS technology is deployed. So how can this committee and should we be thinking about to facilitate improved interagency coordination to allow that faster development and deployment of UAS technology in critical life-saving areas such as disaster relief?
Yeah, thank you for very insightful question, Congresswoman. And this is really important that all the government agencies work together to develop interagency concept of operations and technology roadmap to assist the changes in the firefighting technologies. And we are working with U.S. Forest Service, National Guard, working with Department of Defense, FAA, FEMA, Department of Interior, and many other government agencies, CAL FIRE and Colorado Fire, and to understand really what would it take to change the paradigm of current wildland firefighting and modernize the firefighting efforts, as you pointed out, leveraging the UAS and advanced air mobility type of vehicles, and continue the firefighting through aerial means for 24 hours a day, so they don't have to stop based on just visual conditions. So there's a lot that is ongoing, and we are very excited with the collaboration that we have with many government agencies to bring forward this mutual concept of operations.
Thank you. And then just a quick follow-up. How should federal research agencies work alongside our first responders to actually gather data and learn lessons from what we are seeing now? And it sounds like changing the paradigm really is, a bigger endeavor. But from these limited test cases, which might then use to develop strong safety standards for the broader use of UAS across American airspace?
Yeah, so National Interagency Fire Center that basically currently does many of these coordination efforts does a really good job of bringing out the data and statistics online. In fact, the statistics that I quoted about the 10 large fires that are ongoing right now in 3 states comes from that website. So there is a really ongoing effort already pre-established. There is interagency working groups for number of activities, including aviation and the safety of the operations. And we would like to continue to do that to build the next technology front.
Thank you so much, and I yield back.
Yes, ma'am. Thank you very much. And now I'd like to recognize the gentleman from Florida, Mr. Webster.
Thank you, Chairman.
Yes, sir.
Appreciate it. Happy birthday to you, too.
Thank you.
So I have a question, just a general question to anybody that's there who want to hear about it, is do we have the space for being able to overlay a growing unmanned air vehicle system over top what's already there? I mean, I know there's there's the regular highway system that we have, that's roads and bridges and all that. Then there's a shipping lane highway system, and there's also a in-air highway system for air traffic. So my general question is, are we going to run out of space?
This is a very good, that's a very good and important question. At NASA, we have 4 transformational priorities. One is ultra-efficient aircraft, another one is high-speed regime for flight. Third is future of airspace, and this is exactly what it relates to. And the fourth is advanced air mobility. And the future of airspace, we are working on something called Sky for All. The Sky for All vision is about accommodating many, many different types of airspace users. As you can imagine, in 2045, how the airspace may look like, as you pointed out. Shuttle launches or rocket launches, small drones, advanced air mobility, current manned aircraft, helicopters, general aviation, many types of vehicles. So we are looking at this inside that Sky for All vision. We want to build a new architecture, work collaboratively with FAA and industry, and figure out what would be that right architecture that will allow the scale, diversity, and density that is required to operate in the future state. So we are going to do research on what technologies are needed, what automation is necessary, what will be the roles, responsibilities of people and machines, and how do you maintain overall the safety of operations at that scale. So it's a really important question. It's very much important needed for U.S. competitiveness and economic growth.
A follow-up, this is just a general question. Who would, whoever's guiding that, I'm sure there'll be someone or something or some people or some group or whatever, who do they talk to in an unmanned craft? I mean, who would you, hey, change course or whatever, I don't know. Give me an example.
Sure. Well, at least to date, right, UAS operations they're not actually uncrewed. They're remotely piloted. So there is a pilot for the operation. They're simply not on the aircraft. So it looks a little different, but to your point, right, it's obviously critical that we maintain the safety and also the efficiency of the airspace. That's what the federal government is asked to do, and that's where this unmanned or uncrewed traffic management UTM system becomes really important for the future and needs to be implemented. But when you think about where these UAS are flying compared to traditional aircraft, this is low altitude airspace where generally crewed aircraft aren't or shouldn't be flying.
Okay. My time's going to run out here shortly. I just thank you all for coming. It's a very informative and very interesting subject, and look forward to the future. Yield back.
Thank you. And now I'd like to recognize the gentleman from Illinois, Mr. Sorensen.
I would like to wish Mr. Babin a happy birthday. Thank him and Ranking Member Lofgren for convening this hearing and our witnesses today for their willingness to appear. At our subcommittee on space and aeronautics hearing a few weeks ago, we heard about the FAA's R&D on drones. I'm excited that today we can all learn more about NASA's R&D work in this area, as well as critical issues for commercial industry. So I'd like to ask about the coordination between NASA and the FAA to make sure that we're focused on safety and reliability of the network. Dr. Kopardekar, you've been a leader at NASA on the development of the UAS traffic management or UTM system. What does it actually mean for NASA to have handed off the UTM to the FAA? What has the FAA done with this since then? And I guess a finer point is, how are we ensuring safety to those on the ground and also lower altitude general aviation?
Thank you, Congressman. This is a very insightful question about safety and tech transition process between NASA and FAA. So unmanned aircraft system, basically the focus is on enabling large-scale drone operations at low altitude, below 400 feet roughly, about 55 pound and below type of vehicles. We have been working with FAA right from the beginning. We developed initial concept of operations, and then we had engaging dialogue about how would that work. And FAA also has published the concept of operations, several actually editions, 2 editions on the UTM concept of operations. So that's the first indicator that there is a willingness to take the technology and the concept. So it starts with the concept. So we have a mechanism called Research Transition Team that basically solidifies the collaboration between NASA and FAA. Through their Research Transition Team, we develop a joint management plan, and we have clear deliverables that go from NASA to FAA. FAA is involved every step of the way. So a couple of examples of what it means to be transitioning technology or ideas or concepts from NASA to FAA. First is the concept of operations that FAA accepted and put that as their own, which is really remarkable collaboration example. Second is the FAA's low altitude authorization and notification capability LANC, LAANC, which is really the first step towards UTM. So the concepts that we build in UTM is basically a collection of services to support the drone operations. So one of the services is this LANC, that is digital, basically airspace description that allows operators to get access to that airspace. So FAA has included that. They have already adopted the construct that we created called USS, which is Unmanned Aircraft System Service Suppliers. This is the service, using the service-oriented architecture and third-party basically offering these services. So FAA has already adopted that. So in their concepts and technology and the roadmap, USS and a third-party services providing these services as a critical piece. Fundamentally, in summary, UTM will provide strategic deconfliction. It will provide basically digital means of collaboration across a number of entities, including general aviation and any other users that want to have access to that information can be accessed. And then third-party services will offer services like flight planning, tracking, communication, weather data, and such. So all of those concepts and constructs have been adopted widely by FAA as well as industry, and I'm also glad to say that it's been adopted by ICAO, which is an international body for harmonization across the globe.
In my career as a broadcast meteorologist, I was the person that was out there chasing the tornado. We were the ones that were putting up a drone into the air because we knew that if we could show people at home the threat live on the air, that they could make a good decision. But things have since changed in the past few years, where now we have to have so many people on board to have the line of sight, to have the pilot, and it has become prohibitive for us, or for those people in broadcasting to do their jobs effectively. How do we change that?
Yes. Do you want to answer? Okay, I'll go after
Yeah,
you.
I'm happy
Sure.
to take that.
Thank you.
Absolutely.
Thank
Well,
you.
no, absolutely. News gathering, use cases. There's so many benefits here. And the reality is, like you said, in order to be able to take advantage of the many benefits of commercial drones, we need to be able to fly beyond visual line of sight. Imagine if a crewed aircraft wasn't allowed to leave the airport. That's essentially what's happening right now with the UAS. And it's simply not scalable, and it's not possible to have a business here in the United States under the current rules. So we've been working over the last several years. You mentioned I chaired, or I worked as a leader of a working group on the Beyond Visual Line of Sight Aviation Rulemaking Committee that we provided a report to the FAA last year. And we're looking for a broad rulemaking to actually broadly enable this activity so that you don't have to go through a lengthy, burdensome, case-by-case approval process anymore. That will really, truly help us scale here in the United States.
Thank you so much for that. I yield back.
Thank you very much. And the gentlewoman from Oklahoma, Ms. Bice.
Well, thank you. First, let me say happy birthday to Dr. Babin. It's great to be with you here celebrating.
Thank you.
Second, thank you to our witnesses for being here, and a particular personal point of privilege to Dr. Jacob and Mr. Casey for their attendance. As an Oklahoma State graduate and having 2 children there myself, I'm particularly excited to see you all here. My question has to do with how we're comparing to other countries. In your opinion, how does the U.S. compare to other nations on current progress in advanced manufacturing of UAS? And who would you say are our main competitors in this space? And this is open to any of the witnesses.
Yeah, I'll start with that, and thank you for that question, Congresswoman Bice, and as well as for your tuition support to Oklahoma State University.
You're welcome.
We
Times two.
appreciate that.
Times two.
But, you know, there are areas where we certainly excel in. We've primarily been focused on the discussion today with UAS. When we expand this and talk about advanced air mobility, the larger platforms that are really designed to carry people and larger supplies, you'll see that, you know, primarily through private investment and venture capital, you know, the United States has many companies that are really excelling in terms of the development of these systems. You know, that said, there are other companies obviously across the world that are also, you know, trying to chase that prize to be able to be the first one to really successfully develop systems that can carry personnel cost effectively so that we can compete with other transportation methods. If you look across the broad spectrum of not only just manufacturing, but also research, I would say that the U.S. is still at the forefront in terms of how we're using the autonomous systems, developing the avionics, the controllers, the flight algorithms, the artificial intelligence that goes into these systems into much broader applications. I know the previous questions related to meteorology, that's a great example of that, where we have cross collaborations between federal agencies such as NASA, FAA, NOAA, in order to be able to integrate things such as weather observations from drones into weather forecasting, which is going to be beneficial not only for severe weather, but also things such as wildfires. So there are a number of areas where we're certainly, I would say, still established at the lead.
Any additional?
Yeah, sure. I'll just kind of add on there. I mean, from my perspective and from the perspective of the Commercial Drone Alliance, you look over the history of the United States, and the first century of aviation was dominated by the United States. We were clearly a leader from Kitty Hawk to the moon and beyond, right? The reality is that the second century of aviation, which is characterized by increasingly autonomous, uncrewed aircraft, is at risk. And Congress needs to be a leader here, and we do need to take steps, including to bolster our manufacturing capabilities. As we've talked about, a lot of, most of the small drones flying here in the United States were made in China. So to the extent that the United States wants to remain the global leader, which it is clearly in our best interest to do so, there are, very specific steps that we can take and we can take now in order to make that happen.
Excellent. And last question, quickly here. What is the role of research universities like Oklahoma State to advance innovation in UAS and advanced air mobility?
Well, these really are the sandboxes, and we think about, one of the areas that the United States remains the global leader, it is higher education. People from all across the globe, come to the United States to get an education at a U.S. university. And one of the unique aspects of U.S. research laboratories is the ability to not only conduct research that's funded by the federal government, but also research that's funded by private companies. For example, half of our work in the advanced air mobility in the U.S. sphere does not come from federal funding directly, but from private companies helping them get over that hump, to develop that technology where they do not necessarily have that subject matter expertise in-house. So we're working with a number of companies that are performing system development for other federal projects such as Agility Prime in order to be able to develop those systems for everything to fight fires, to be able to carry people. And it's that research laboratory, that sandbox, that really provides a unique opportunity to be able to develop the systems in a lab and immediately go out and take them to test sites, such as supported by the Beyond program.
Perfect. My time is about to expire, so I will say go Pokes, and I'll yield back to Dr. Babin.
Thank you very much. I'd like to recognize now the gentlewoman from Michigan, Ms. Stevens.
Thank you, Mr. Chair, and thank you to our witnesses. Ms. Ellman, we on this committee, we talk a lot about standards. We have oversight of the NIST, and I'm interested in your perspectives on the standards needed here and work that has been done to date, particularly as we integrate here. So I was wondering if you could chime in on standards for us.
Absolutely. Thank you, Representative Stevens. Great to be here with you. My home state is Michigan. born and raised, so great to be here with you. And I appreciate that question, and we agree standards are critical. Industry consensus standards should really kind of drive how the UAS industry is able to function and scale. And our members are working very closely with standards body within the context of existing standards bodies like ASTM International. There's been a lot of great work that has been done by industry. I think one of the challenges has been that we don't have clarity on the rulemakings on the regulatory side, and so it's very difficult to, then the rulemaking comes out later, and then you have to go back and kind of change up the standards. So the more information that we can get from the FAA, working closely with them on the rulemakings, I think would be helpful. But certainly there's a lot of great work that's being done on the standards side with ASTM International, as well as other standards bodies, and we would encourage Congress to really leverage those.
Yeah, and PK, I can see you're jumping at the bit here. And I, if you want to chime in on standards, but it's always the thing we're balancing, right? Standards and R&D, and it's interesting because when we think unmanned, all right, no one's flying the drone, right? No one is actually flying it, but is there ever a component where someone would be riding? Do we get to that? We've seen that obviously with commercial aircraft. Well, pilots and this and that, but we don't need to get into that. But I'd love to hear from you on cross interagency standards as it relates to. I was going to ask you about R&D as well, and thank you for the amazing testimony and how you're working across interagency.
Yeah, so a couple of areas we are working really well. In fact, I was here last couple of days for interagency working group that OSTP and Department of Transportation just kicked off to coordinate all the activities as per the Advanced Air Mobility Leadership and Coordination Act. So all the 19 federal agencies are coming together to make sure that we understand and respond to the growing needs of advanced air mobility. So this is really a good testament of collaboration as one government trying to respond to what's needed. And that's one of the lessons we learned from drones, that I think it really helps to have one government, all of us working together, right from the innovation, technology, security, safety aspects considered simultaneously.
Do you think standards would help R&D?
In some cases, standards help R&D. In other cases, it's too early for standard, or sometimes you need just cooperative guidelines. So some of the examples of standards, particularly would be the detect and avoid technology. If you want to have detect and avoid, everybody needs to follow the same standards so that there is a cooperative nature in the airspace management. So detect and avoid would require a standard. As an example, it's capability that's on board.
Well, and this is where, Ms. Ellman, we can continue to draw on your coalition and your alliance. And thank you for your leadership. It's great to see Michigan launch into such an exciting place. And Dr. Jacob, I love that you got EDA funding, all right? And I actually wanted to specifically ask you about the pocket of EDA funding you got. Was that out of the Office of Innovation and Entrepreneurship? And how was your process in pursuing that funding? Are you going for other rounds? Do you see this? And I've been to EDA conferences, or EDA Align. I've been to one EDA Align conference in Oklahoma in another life, but I was pleased to see that you mentioned that because, in part, this committee works with EDA and has a dotted line to it, and certainly want to ask you about the cross-interagency collaboration, but very specifically about your experience of working with the Economic Development Administration as much as you have purview into the dollars that you were receiving from that agency.
Sure. Thank you for that question, Congresswoman Stevens. And the EDA opportunity has been very unique, has been part of the Build Back Better program.
Okay, great.
So we're still just in the initial stages of that, but that is a great example of a public-private partnership where we have private funders that are providing part of the required cost share from Tulsa Innovation Laboratories, working with sovereign nations, in this case the Osage Nation, and then Oklahoma State University, as well as other partners across the Tulsa region in order to be able to make this.
And I am out of time, but we want to applaud you for how you're working with Indian country and certainly keep up with your success on the Build Back Better. We had a hearing on that right at the end of the last term. So thank you so much, Mr. Chair, and I yield back.
Thank you.
Thank you. I'd like to recognize the gentlewoman from North Carolina, Ms. Fushi.
Thank you, Mr. Chairman, and happy birthday.
Thank you so much.
And thank you to our witnesses for appearing before this committee today. I certainly appreciate this productive conversation with you about unmanned aviation sector and the potential considerations as we deliberate possible legislation in this committee and in the months ahead. Just last month, I visited Vance Granville Community College. They have an aviation program in my congressional district, which is North Carolina's 4th. That program specializes in training commercial drone pilots and preparing students to become FAA Part 107 certified. And recently, they were selected for the FAA's Unmanned Aircraft Systems Collegiate Training Initiative Program. The 4th Congressional District is also home to Carolina Drone Lab, which I will talk a little bit more about in my questioning. So my first question is for Ms. Ellman, and Dr. PK, if you can respond also. UNC Chapel Hill's Carolina Drone Lab has partnered with 2 organizations, Vets to Drones and One Tree Planted, to create the Veterans in the Forest program, a partnership to train veterans and provide on-the-job experience in drone-based forest monitoring technology. Can you speak a little bit about the importance of developing UAS training programs and the opportunities for workforce development with the civil science agencies under this committee's jurisdiction?
Absolutely. Thank you, Representative, for that very important question. It's a very special one for me. My husband is actually a disabled veteran, and I know that finding a rewarding career is one of the challenges for service members face when transitioning out of the military. So, you know, from our perspective, absolutely, the UAS industry is democratizing aviation and opening this industry up, opening doors to a diverse and new generation of Americans that are incredibly excited for this new, to use their skill sets, you know, for the benefit of so many of the societal benefits that we've talked about today, including, and as NCDOT and others are supporting your state, whether forest monitoring or other use cases. So we are, you know, very supportive of efforts to promote workforce training programs. You know, I would mention the DIG Act, which was passed by the House last year, and a bipartisan bill that would, one of the sections of the act would fund a workforce development program for community colleges and universities who are training workers in drone technology. So thank you for that. You know, so we would urge more support for that bill this year. Hopefully it'll get through, and we're here to help. We appreciate the question.
Thank you. And Dr. PK, can you also share if NASA is involved in any such effort?
Yeah, thank you. This is a really important question, and the importance of this question is to make sure that we ensure that our workforce is ready when the drones and advanced air mobility industries are going to take off. So at NASA, we have a number of initiatives. The first one is Minority University Research and Education Program. Through that, we have given 6 grants already for building advanced air mobility-related supply chain, workforce, curriculum, and internships for students. There's another program called University Leadership Initiative that we provide grants for faculty members who focus on some interesting technical challenging problems. So one of them is the weather-related research. So another one is building this concept of operations at different communities for advanced air mobility. And third, and very exciting program is NASA Community of Aerospace Scholars, which is focused on community colleges. So we work with community colleges for building the trade and technical competency of students. On top of that, we have a very strong internship program. Anybody is interested in internships, intern.nasa.gov. Please ask them to apply. We really take pride in getting good interns at all NASA centers. And personally, I have a steady stream of interns every semester. This semester, we are focusing on wildland fire applications. So I really enjoy working with interns and getting to know them and mentor them.
Thank you. Mr. Chairman, that is my time, but I would like to add 3 additional questions for the witnesses into the record.
So ordered. Thank you.
Thank you.
Okay, the the gentleman from Ohio, Mr. Miller.
Thank you, Mr. Chairman, and thank you, Ranking Member. I'm happy to hear today about NASA's involvement in the future of American advanced air mobility. As we're all aware, Chinese companies such as DJI make up overwhelmingly majority of the global unmanned aircraft system market, including for American law enforcement and consumers. This is even after the Department of Defense prohibited DJI products for national security concerns. Clearly, we need to restore American leadership in this sector, and fast, lightning fast. My first question is really for any of the witnesses who would like to take it. As China continues to aggressively pursue Made in 2025 policy to achieve dominance in critical industries such as aerospace, what are some of the short-term and long-term actions the United States should take to promote American leadership in this space?
Thank you, Congressman. I think really one of the primary things we can do is actually support manufacturers like my business in actually getting DIU Blue certification. Specifically, what the S&T committee can do of a high priority is establish their own equivalent within the scientific and technology community where we can actually offload vetting from the DIU, which is actually a group of approximately 5 to 10 PMs that vet all the drones in the entire country to give you guys stabilized systems for acquisition. If not currently, we're not going to have a usable system, and a lot of these higher-end regulation arguments to manufacturers like myself are like arguing about highways before we have cars. And we need to focus on visual line of sight and small platforms that we have immediately that we need to scale up to counter the CCP policy that is going after our capability set. Yeah. Thank you, sir.
Thank you for that answer, and I just wanted to underscore the seriousness of where we are and where we're lacking and how far behind. My next question is for both Dr. Jacob and Dr. PK. What research is being done to assess training needs and future workforce development to support future advanced air mobility operations?
I'll take this short and be brief. Thank you again, Congressman Miller, for your question. We're really focused on the training side in terms of being able to provide the capabilities through, for example, the Counter-UAS Center of Excellence to train soldiers and warfighters to be able to evaluate not only how to use systems to detect, identify, and defeat UAS, but also the UAS themselves. This is one area where the technology is changing so rapidly, it becomes very difficult for federal agencies to be able to keep up with the technology, and obviously that's one area where universities excel at and are able to rapidly turn that around.
Thank you. Yeah, thank you, Congressman, for that important question that's focused on the workforce and the needs of the advanced air mobility industry. Practically every advanced air mobility industry member is right now hiring. And we have a number of initiatives inside NASA that basically allow students as well as faculty members to grow the curriculum and train the next generation workforce. The first example is Minority University Research and Education Program grants. We have, at the moment, we have at least 6 grants focused on U.S. manufacturing and supply chain, your prior question, in this area. Second example is University Leadership Initiative, where we provide grants to the faculty members and allow student competitions and participation from students to push technology frontier forward. So one of the examples is the weather. Third is the NASA Community of Aerospace Scholars Program. This is working with community colleges to bring them ideas and nurture them into the aerospace trade. And as I mentioned also, we have a strong internship program that allows a lot of students from all over the United States to be part of the internships at all NASA centers. And it's a really joy to work with the interns and mentor them.
Yeah, it's a wonderful thing. Dr. PK, in your testimony, you also discussed how NASA leverages several programs, including the Small Business Innovative Research Program, University Leadership Initiative, and Minority University Research is what you just mentioned, education program to award grants to advance unmanned aircraft systems and advanced air mobility capabilities. Could you provide us with an example of how NASA's grant programs have enabled innovation in this space? And I believe you already just touched on that to some extent. So
yeah, and I'm happy to reiterate that. I mean, for the Minority University Research grants, we are focused on building supply chain understanding, new curriculum for supply chain, and bringing businesses, entrepreneurs to actually start supply chain with manufacturing in different parts of the country, including opportunities for students to do internships and jobs in this marketplace. So that's one example. Under University Leadership Initiative, we are working with faculty members such as Jamie here on a number of topics. One of them is weather and figuring out the needs of the weather that are required to support the safe advanced air mobility operations. Another one related to University Leadership Initiative is building concept of operations to enable these vehicles and their operations in different parts of the community.
Thank you, Doctor, and I just want to thank all of the witnesses, the chairman and the ranking member, and I yield back. Thank you all.
Thank you very much, and I'd like to recognize the gentleman from Illinois, Mr. Caston.
Thank you. I'm tempted to lead off with a rousing chorus of happy birthday, just to be different from everybody else. But in the interest of all involved, I will keep my singing to myself. Yeah, you're welcome. So thanks so much for this panel. I find myself sitting here thinking of my dad has this, one of his sayings is that if you found someone's strength, you found their weakness. The strength of drones is that they're unmanned. They can take off and land anywhere. They can carry a payload. They can fly in unregulated airspace. And I have, of course, also just described their weaknesses, depending on what that payload is and where you'd like to travel. As I realize I'm speaking the obvious. I guess I'd like to start, Dr. Kopardekar, with a philosophical question for you. I know we're considering various legislation and not asking you to opine on legislation, but every new transportation technology that's ever come out has had some balance of device-level regulation and public space-level regulation. You know, flight paths, shipping lanes, the GPS chips that prevent your electric scooter from getting onto the Capitol grounds, right? You know, we can think through all those. As you think about a world that doesn't throw out the baby with the bathwater, but, you know, plays to the strengths of drones and, you know, while recognizing the vulnerabilities, philosophically, how do you think we should be thinking about that balance? And I ask the question philosophically because that also spans a lot of committees of jurisdiction in Congress. But is there anything unique about drones, or is the approach we've taken to the sort of ad hoc basis that we've done for other technologies the right way to think about drones as well?
I think it's a very insightful question, and thank you for asking that question. If I may offer an example from the NASA experience itself. So last year, about this time, there were over 50 incursions on NASA Kennedy Space Center near the launch pad. A few months ago, DoD found about over 200 incursions of unwanted drones over Kennedy Space Center. And what that does is it actually jeopardizes the safety of the launch systems and the people and the assets that we have and the schedule integrity. So it's really important that we have balance of basically push forward as well as the right type of legislative authorities. So as a result, NASA is requesting regulatory authority for detect and track these drone operators that are operating and should not be operating over NASA properties. So we have seen similar things happen at Johnson and Stennis and a few other centers. So it's a really balance of push forward and at the same time making sure that that it doesn't go into the bad hands or the bad actors are not able to make damage. So
okay. I'd love to open up, Dr. Jacob or Ms. Ellman, if you have different thoughts on this, would love to hear it as well. And if you could layer on the international component of this. You know, Ms. Tenney talked about drones moving, you know, contraband across borders. What we can regulate in our own airspace is going to be different, but, you know, the devices can move. How would you suggest we think about that philosophical trade-off between device level and public space level?
Absolutely, no, and I really appreciate this question. As the chair noted, I previously worked in the federal government. I still remember the first meeting that we had at the White House where we talked about what does it mean to integrate UAS into the national airspace? Drones can be used for so much good. They can also be used for harm, as you note. And I think the key here is how do, like you're asking the right question. How do we enable the good about this technology while preventing the bad? And there are a few different aspects to preventing the bad, right? The first is situational awareness in the airspace. How do we know who is flying out there? And that's where remote identification comes in.
And I'm sorry, when you know who is flying, is that identify the device or the pilot?
It's essentially a digital drone license plate. So it's a digital drone license plate, so you would be able to identify the device by a license plate number, and then if it is, unauthorized, flying, for example, over a stadium, you'd be able to, the law enforcement would be able to get access to who is the operator.
So I can get back and see who is actually flying it at that time.
Exactly.
Okay.
So it provides a tool to law enforcement to actually enforce the laws and rules that are out there. But that's just the first step, right? The second step is what do you actually do if you're in a situation where, a drone is being flown, rogue drone flying where it's not supposed to be. You can't, right now, under the current laws, you're not actually allowed to do anything about it. There's no mitigation authority. And that's where, we see innovation and security as two sides of the same coin. So we think there needs to be common sense steps forward to enable companies that are developing this technology, both to test that technology here in the United States, as well as to work with right now it's only 4 federal agencies have access to this technology, and that needs to change for our national security.
I'm out of time. Yield back. Thank you.
Thank you. Now I'd like to recognize the gentleman from New York by way of Texas, Mr. Williams.
Thank you, Mr. Chairman. I'd like to welcome our guests as well. And I'm sorry that I think Major McGarvey and his crew have left. I would offer them greetings from their colleagues from the 174th Attack Wing that is headquartered in Syracuse, New York. We're very proud to have them there. There's a lot going on with drones in New York's 22nd District, which I know you're aware. So forgive me for a few statements here, but we have one of the most significant drone test sites in the world, run by New Air, a 50-mile corridor and test corridor that connect Rome all the way to Syracuse Airport, as well as in other areas. The Syracuse Airport is also the only FAA licensed airport that allows unescorted, unmanned takeoff and landings, which is critical for testing of drones. So we invite all participants to join with us in this exciting innovation, visit, invest, grow with this amazing community in beautiful central New York. Mr. Casey, just for a moment, my grandfather worked on B-24s and B-29s at Tinker Air Force Base and spoke of it with great affection his whole life. So Tinker is part of our family story. And Dr. Piquet, just one more biographical note. Several years ago, I was privileged to brief your ATMX team at NASA Ames, and they were investigating next-generation technologies that would be essential to manage airspace when you have a 3 orders of magnitude increase in the number of aircraft, right? 1,000 times increase. How do you deconflict that? We can't do that with current technologies. And it was a privilege to talk to the NASA team there. I look forward to partnering with you on that. But I just have a couple of questions. Mr. Casey, there are some domestic concerns about incorporating components, we've heard about that today, from China into American drones. To the extent that you've not covered that, what are some thoughts about how we can do that? Is this, is it rulemaking? Is it a demand signal, so that we get outside investments? Are they asking for subsidies? What's the real solution there?
The real solution, honestly, lies in acquisition. It really, to me, from a manufacturer's point of view, this has nothing with regulating niche categories of application. We need to make a domestic capability very quickly. To do so, the government needs to become a buyer of drones. To do that, the government needs to actually accelerate NDA Section 848 compliance and actually maybe even support funding to actually go after that for a lot more small business. It's important to note that most of the actual UAS community is entirely small business, as in less than 500 employees, and the SBIR programs are really impactful for us. And in general, we need to actually make these components at home, and we don't need to make them in Europe. We don't need to make them in not just non-China countries, but we also need to loop in funding from the CHIPS Act to help support this effort as well. because really we're having an issue in the critical components of semiconductors and chips as well, and the software and the actual command and control algorithms that we run being China origin as well.
Great, thank you. Thank you. I appreciate that detail. I think that's very helpful. Mr. Jacob, could you comment about how the FAA currently uses the data collected by the FAA at these UAS test sites, like in my district? Is there anything the federal government, can leverage from these test site data for our defense priorities? I love dual-use technologies. So for counter UAS or advanced air mobility, are we able to repurpose, this data of what we're learning to meet our national defense needs?
Yeah, certainly. Thank you, Congressman Williams. That's an excellent question. First off, New Air is really doing great work. They've been really crucial in terms of pushing the boundaries of what we've been able to do in integrating U.S. into the airspace. In terms of the data that the FAA is acquiring from these test programs, and it's not just these programs themselves, but all UAS that are operating within the national airspace as part of the certification process, getting approvals to fly in the airspace. We're required to report back how those vehicles are actually operating. And it really comes down to providing safety data from the use cases. How well are those vehicles working? Where are the failures at? Really what's breaking in the system so that the FAA can then use that data to determine how best to safely integrate those aircraft in the national airspace. For the DoD side, that data is just as useful in terms of determining how those aircraft then can be integrated not only to the day-to-day operations of the DoD, but also then how to utilize counter-UAS systems to be able to evaluate them. And some of this goes back to something that Mr. Casey mentioned in terms of getting approvals for blue or approved U.S. Manufactured aircraft to be able to utilize those more into the airspace, but also that approval process so that way we can streamline that and have states such as Oklahoma, which are working on their own blue UAS approval program, to be able to more rapidly approve aircraft for flight in the U.S.
Thank you for your detailed answers. That's helpful. Come fly with us in Central New York. Thank you. I yield back, sir.
Thank you very much. And now I'd like to call on the gentlewoman from Ohio, Ms. Sykes.
Thank you very much to the chair and ranking member for this meeting. And Chair, happy birthday, but next time let's get some cake.
Yes, ma'am.
Thank you. As my colleagues and I discussed last hearing, we all know Ohio is the birthplace of aviation, and Ohio is the nation's largest industry supplier in the Air Force industry. Ohio is one of the first states to release a market impact study for the urban regional air mobility program, and we are releasing the nation's first advanced air mobility framework. One of the things that is incredibly exciting about the state that I'm from, particularly in Northeast Ohio and Ohio 13, is that we're seeing an opportunity to be leaders again. And I heard Ms. Ellman talk about the first generation of aerospace and flight and aviation, and we have an opportunity to do this the second time around if we use our opportunities appropriately. And so to that end, one of the things we hear from every industry, almost every company that I'm talking to across the district, is an issue with workforce. And I'm incredibly proud of my alma mater, Kent State University, that this month just instituted an unmanned aircraft systems flight operator management, or major, excuse me, to help that workforce. And Dr. PK, I heard you talk about this as well, because there are a lot of opportunities from NASA, and NASA Glenn is a highlight in our area. One of the things about this job that I love the most is the information that I get and how I can help my constituents. But the thing that's most frustrating is, how do we get that information to our constituents so they can use it? And you talked about your internships, and I'm talking about college-level degree programs, but how do we get the workforce interested before they even step into high school so that their pathways can get them into the air or in a remote facility working through this process? So could you talk a little bit more about those early interventions so we can get those workforce pipeline issues sorted out?
Very astute observation, Ms. Kikes, and really appreciate that. And thank you for all the great work that happens at NASA Glenn. They are really the champions of propulsion, and they've taken a lot of interest in advanced air mobility, including the Department of Transportation in Ohio. that's setting up, as you mentioned, advanced air mobility framework. And by the way, my daughter also goes to Case Western University, so I have a little personal connection there. But your question is very valid. How do we entice students at the early stage into STEM workforce? And we have several examples and several programs that at NASA that basically go to different colleges and high schools and middle schools and even some elementary schools. I know I used to personally go to many schools and give talks and inspire students to come join and think about space and aeronautics as future career options and get them excited. We will be more than happy to take the question back and give you a list of different programs we have that will allow you to share that information.
Thank you so much for that question. And so the second thing we hear a lot about, no matter where we are after workforce, is typically a regulation and regulatory frameworks. And the Fly Ohio program specifically identifies that the lack of federal government or the federal government restrictions, I should say, on flight to operate low altitude air traffic is one of the things that's hindering us. And Ms. Ellman, I know you talked about this as a industry leader. Could you dive into a little bit deeper, more specifically, what it is that you would like to see? What does the industry need to see? And I'm saying this particularly for the economic benefit of those of us in Ohio. This is a billion-dollar industry that we're not tapping into. What could we do to harness that, get that money to Northeast Ohio, particularly Ohio's 13th congressional district?
Absolutely. Thank you so much for that question, Congresswoman Sykes. It's a critical question for industry. It's also a critical question for states and localities like Ohio. You guys are doing great work developing a corridor. I hear all the time from our member companies that are looking to do business in Ohio, so we really appreciate your leadership as well. From what we all collectively need is to move the policy boundaries forward. The technology has moved quickly forward, the policies have lagged behind, and we're still waiting for rulemakings, broad rulemakings that would make it, that would relieve the undue burden that's on these regulatory processes in order to be able to scale businesses here in the United States, including in Ohio. And so, we appreciate the opportunity to be here today. We also, the regulations also need to move forward even to enable advanced R&D. So, this is a critically important issue for all of us, and I'm really, we'd be very happy to work with you in your office on how we can bring these benefits to the state of Ohio and across the country.
Thank you, Chair, and I yield back my time.
Thank you. I'd like to recognize the gentleman from Alabama, Mr. Strong.
Thank you, Mr. Chairman, and thank you to our witnesses for being here today. Happy birthday, Mr. Chairman. I have the honor of representing a district on the cutting edge of aerospace and UAS innovation, Huntsville, Alabama. Alabama's 5th District holds a large contingent of key players in this space, spanning DOD, DOJ, DHS, NASA, and hosting a thriving ecosystem of universities and contractors. I'm proud of the continued work and role our entire community plays in the research and development, detection, and mitigation of evolving UAS threats from our adversaries. North Alabama is a prime example of the success that is possible when you put everyone in the same room to come up with solutions to these issues facing our country. In our case, when you get everyone together in the same region with some of the brightest minds in the country, it's been very beneficial. Nowhere else can you find a community more dedicated and well-positioned to address these problems head-on. Time and again, we prove the value of a whole-of-government approach to these threats, and even more so, the value of interagency partnerships and relationships. Ms. Ellman, you're doing my job for me. I was glad to see in your testimony highlighted the important work of the universities in my district. The University of Alabama in Huntsville is currently participating in various UAS-related projects. They continue to excel in this field and deliver valuable support and expertise to partners. I know you mentioned that we have only scratched the surface of the capabilities and applications of UAS technology. Can you talk more about the importance of universities in the future of UAS?
Absolutely. Thank you, Congressman, for that question, and thank you as well for the great work that is being done across the state of Alabama, including University of Alabama, Huntsville, for the great work that is being done in the research and development that your state is doing to advance this industry. And absolutely, universities are a key partner to industry. We greatly appreciate our relationship, including with Jamie and his team, as well as the federal agencies and others. But universities are doing great work in trying to do more work, research and development. Unfortunately, they are limited by the regulatory frameworks, just like industry is. And that's where we really need to take a risk-appropriate approach. How can we enable these operations, including for research and development, in a way that allows us to maintain our global leadership in advanced aviation? And so we would be happy to work with you. We have lots of ideas in that respect. I've mentioned one issue around public aircraft operations, but there are others as well, and I'd be happy to work with you and your office on this important topic.
Thank you. Specifically, what is needed to better leverage and benefit the efforts of UAH and other institutions?
Well, one of the challenges is, as a company, if I want to work with UAH in order to do research and development on, let's say, a vehicle that I don't even have the ability to do on my own private property, these operations, I currently, under the current rules, am not allowed to actually use that data or have access to that data or use those for certification processes. So working together so that we're able to eventually commercialize, which is the purpose of research and development, to commercialize these technologies is an area that I think we could work together on.
That's great information. Dr. Jacob, can you talk about the importance of community and agency partnerships in the work that you do?
Certainly. Thank you, Congressman Strong. And I would like to say, really appreciate all my visits to Huntsville. We work very closely with Redstone Arsenal through the Counter U.S. Center of Excellence, and particularly CC DevCom and AVMC. So it's fantastic to be able to come out and visit your district. As Lisa had mentioned, the university impact is really limited by access to the airspace and be able to test the systems. And we've certainly found that not only in terms of what we're evaluating on the counter UAS side, but then how we take this out to the community. When we engage not only the community, that's where we start to educate the public about how UAS can be used for both good and for ill, how they're going to be integrated in the airspace, and we start to be able to spark those ideas from community members about not only acceptance of the technology, but also entrepreneurial ideas about how they can use the systems to be able to start up new businesses or engage with their community. But furthermore, that's a fantastic way to develop a workforce for the future by exciting kids in the K through 12 arena about the possibility of drone technology. When you combine robots with aircraft, you just really spark imaginations.
Thank you, Dr. Jacobs. I yield back, Mr. Chairman.
Sorry, thank you very much. And now the gentlewoman from Colorado, Ms. Carveo.
Thank you, Mr. Chair, and I join everybody in wishing you a very happy birthday.
Thank you.
And thank you to Chair Lucas and Ranking Member Lofgren for putting this together, and to the witnesses for taking the time to speak to us today. I am a physician, and so view a lot of legislation through what this is going to do to the world of medicine. With every new technology is a way to change the way that medicine and emergency services in particular are delivered. And sometimes the rollout is slower than we would like. I think in particular with the internet and how long it took for that power to really be harnessed in terms of telemedicine. It wasn't really until the COVID-19 pandemic that we really took full advantage of it. And it has really revolutionized the way that patients seek medical attention. And so I'm wondering, with this technology around unmanned air systems and drones, how you think that these may be applied to emergency services in particular, coming from a state like Colorado. I think in terms of wildfire response that we have discussed earlier during the hearing, and in particular the access to places that are remote or not accessible because of emergencies, and then overall to the delivery of medicine and emergency response in general. And that goes to any of you who think who have something to add.
Yeah, if you don't mind, Congresswoman. I'll just jump in real quick and provide some examples, because this has been one area that we've been actively participating in with small businesses to be able to evaluate technology, to be able to deliver emergency medical supplies to first responders in the field. Both firefighters, emergency medical technicians, such as blood bags for a car accident. And this is one area where UAS will be able to provide really rapid responses that we don't currently have. As an example, going back to your comment regarding COVID-19, we actually were partnering with the Choctaw Nation to evaluate the implementation of medical delivery and other emergency aid delivery during the pandemic, but we're unable to get approval for that for the test processes from the FAA. So the Choctaw Nation was exploring that as part of the Beyond program, and that just provides an example where we do think there are opportunities that are currently being missed.
Sure, and I'll just add to that. First of all, the medical use case is a fantastic use case, and thank you for your work as a physician. Obviously, incredibly important what you're doing, and there are companies that are trying to fill that void. There are pharmacy deserts. There are so many different use cases in this business, and it's already happening at scale around the world. So Zipline is already delivering vaccines, for example, at scale nationally in Rwanda and elsewhere in other countries around the world. Wing is delivering, working to deliver prescriptions and other critical supplies. So is, Matternet is delivering blood samples in Zurich. So there are lots of companies out there that are trying to do this work. Again, and there's so many different, it helps vulnerable populations in remote areas, like you mentioned, the pharmacy deserts. So there's so many different applications and so many different use cases here. The key is really unlocking this potential with the regulations.
And any further comments on barriers and particular challenges? I know that we've talked about research and the permitting process, for lack of a better word. Anything in particular to the delivery of medical services that we should be thinking about when we approach legislation?
Sure, Congresswoman. So to be perfectly clear with the Blue compliance, if you want it to be a federally deployed system, if this payload has a single logic level chip, that payload is going to be subject to country of origin restriction. And right now, again, because the government's not really acquiring these systems, there's not an emphasis on commercialization. The emphasis is on research, without commercialization. But ultimately, right now, at this point in time, for these necessary services, we need the commercialized product. And to do so, we need the acquisition support.
Thank you, Ms. Ullman. Go ahead.
Yeah, I was just going to say, for commercialization of this technology, another area just to be aware of is hazardous materials. So sometimes if you're carrying, for example, a vaccine sample that could be considered hazmat under the rules, that's an area that hasn't really caught up to the technology. So we'd be happy to work with you in your office on that important topic.
Be very interested. Thank you all so much. I yield back my time.
Yes, ma'am. And now the gentlewoman from Pennsylvania. Ms. Lee, thank you.
Thank you, Mr. Chair, and happy birthday, of course.
Thank you very much.
As many are aware, and one of the things that I'm most concerned about is how marginalized communities they face a range of challenges, including limited access to resources, restricted mobility, and reduced opportunities for economic and social advancement. So while unmanned aircraft systems or drones are often associated with use in wars, they have the potential to revolutionize the way we approach the challenges by providing an innovative way to provide support to those who need it most. Drones offer opportunity, as we've learned and as we've heard, to deliver medical supplies like vaccines to remote and underserved communities, or providing lifelines to those who might otherwise be unable to access these critical resources. I think about what access to drones could have meant in relief efforts such as catastrophes like Katrina. And others were providing a rapid and efficient way to assess damage and deliver aid to affected communities, as well as to provide proactive preparedness warnings in the event of extreme weather occurrences. But while unmanned aircraft systems have the potential to help bridge the gaps between marginalized groups and the rest of our society, we also have to be mindful of the potential risks and challenges associated with their use. So we must ensure that drones are used in a safe, responsible, and ethical manner. and that they don't exacerbate existing inequities or create new ones. With that said, my first question is to Ms. Ellman. What will U.S. leadership in drones technology look like, not solely in terms of market share, but in reducing socioeconomic disparities in our country and improving overall standard of living?
Absolutely. Thank you, Congresswoman, for that very important question. This technology can promote equity and can promote, you mentioned medical delivery, pharmacy deserts, whether it's rural areas, poor areas that don't otherwise have access to medicines, or whether it's the inner city and we're trying to make infrastructure inspections more efficient, for example, make the best use of taxpayer dollars. This industry has the potential to really boost our efforts to promoting equity. And so that's something that this industry is really committed to, and we'd be happy to work with your office to continue to find areas that this industry can be supportive.
Thank you, and I'm happy when you mentioned, infrastructure checks. Obviously I come from Pittsburgh where we had a bridge collapse, and one of the key concerns is how are we, checking them, how are we updating them? And one of the proposals from someone in our district was talking about, equitable access to that and using drone technology to lead that. So I'm certain that one constituent would be really interested in this research and this technology as it emerges. Dr. Kapotekar, how is research and development creating new opportunities and avenues for domestic manufacturers and suppliers to become full participants in expanding aviation value chain? Or in this expanding aviation value chain, excuse me.
Yeah, thank you for that great question. I think it's really important to ensure that we have a strong supply chain for aerospace and defense to maintain the U.S. competitiveness as well as maintain the jobs in the manufacturing sector in the United States. So one of the things that we are doing is working with Department of Defense, Agility Prime Initiative, and NASA. We are collaborating together and informing the advanced air mobility industry members as well as small and medium-sized enterprises as to where the jobs are, where the manufacturing capability is needed to support the U.S. and advanced air mobility technologies and manufacturing. So understanding the needs of the new growing entrants as well as opportunities for domestic manufacturing sector to grow is very important, and we have been successful in getting some new entrants, new companies to match with some of the advanced air mobility organizations.
Thank you, and thank you so much to the panel for your time and for the information you shared today. I yield back, Mr. Chairman.
Yes, ma'am. Thank you very much. And the gentleman from California, Mr. Obernolte.
Oh, thank you, Mr. Chairman. Happy birthday. I want to thank Chairman Lucas and the committee staff for holding this hearing on a really important topic for me. I'm the chairman of the Advanced Air Mobility Caucus here in Congress, and we have been working to try and raise awareness of the benefits that advanced air mobility and unmanned aerial systems can bring to Americans, but also some of the difficulties and the challenges that lie ahead in both of those sectors of our aviation ecosystem. So, I think I share the opinion with a lot of members of Congress that advanced air mobility is on the cusp of delivering a transformational generation of expansion of mobility in our airspace system. It's going to bring a whole host of benefits to American society, and I think it's going to catalyze not only mobility but also access to resources for Americans in ways that haven't been done before. But before us lies this challenge of, first adopting certification standards for AAS aircraft and then integrating them into the National Airspace System. And there lies the difficulty. We're kind of grappling with the certification problem now, but next, and right on its heels, will be this problem of integration. And we've just been through this with UAS. And Ms. Ellman, I was interested when I heard your testimony about the challenges that we went through. I mean, Congress was exactly here 11 years ago. In 2012, Congress passed a legislative mandate that directed the FAA to get going with respect to the integration of UAS into the airspace system, and yet, here we are still 11 years later grappling with the same issues. And unfortunately, I think this exposes, two things. First of all, the fact that quite often the bureaucratic default stance when confronted with uncertainty is immobility. And second, the role that Congress has to play in helping the FAA, and it's not an adversarial relationship, but helping the FAA try and get itself in gear and get past some of these hurdles, kind of grapple with this trade-off between uncertainty and the need to protect public safety. So, Ms. Ellman, you'd highlighted this, and I'm interested in your point of view on integration for AAS. Having just gone through this with UAS, what are the lessons learned, and how do we avoid making some of those same mistakes?
Absolutely. Well, thank you, Congressman, for that very important question. And thank you for your leadership of the AAM caucus here in Congress. I think that's incredibly important work and look forward to working with you in that capacity. Absolutely. There's, I think of AAM and UAS on a spectrum of advanced aviation. There are certain things that they have in common. There are certain things that are different. But the reality is there's a lot of things that are complementary in terms of there are new entrants into the airspace and low-altitude airspace and trying to figure out both the technology piece and the policy piece and how it all fits together. There are certainly many lessons learned from the UAS space that the AAM community can kind of take heed of. One, I was encouraged to see this federal government working group that's been established with the legislation that Congress passed, the AAM Leadership and Coordination Act. That is a positive step forward. I'm pleased to see that it has been launched and that the federal government is working, because it's very important to have a holistic, whole-of-government approach. As you said, it's not an adversarial relationship with any government agency. There are very good people trying to fit a square peg into a round hole. They can't. It's not necessarily their fault. The challenges are systemic. Anytime you introduce a new technology into an existing regulatory environment. I will mention one thing in particular that challenged the UAS industry, that the AAM industry is kind of keeping its eye on, which is that security issues were not considered early on in the UAS space, and that ended up pushing back expanded UAS operations several years as the national security agencies then came forward and said, wait, we're a stakeholder too, you need to consider our concerns. So that's part of why I look at this interagency working group, and it's a very positive step forward, and we need the national security agencies to participate and be active participants in not only identifying challenges, but also providing solutions.
Well, great, thank you, I agree with you. Dr. Kaparnikar, if I could ask, because I know you've got some expertise in this subject, so now we're considering AAM and UAS kind of in the same sentence, because we failed to get there with UAS. We're still grappling with the same problem. Does tackling this challenge with both of them put together either simplify it, or does it make it more difficult?
First of all, Congressman, thank you for your leadership of Advanced Air Mobility Caucus, and really appreciate Armstrong. I have fond memories of visiting Armstrong and great friends there as well. We are working together with them on the wildfire activity as well.
Right, I'm aware.
Yeah, so thank you for that. But yeah, in terms of combining things and not combining, there are a couple of things that we can probably combine. For example, interoperability and operations inside airspace. I think everybody has to coexist in the same airspace at the same time. So there are a few things related to advanced air mobility that are similar to drones, particularly larger drones, using basically the tenets of unmanned aircraft system traffic management, which are digital systems, cooperative nature, sharing the intent, and using third-party services to get faster, basically acceleration of their introduction. So these things are common between the US and advanced air mobility. What's not common is advanced air mobility has a series of basically waves, if you will. Some of them are in the beginning, are going to use piloted operations under clear visibility VMC conditions, VFR kind of setups, whereas the drones, the smaller drones, they don't have pilot on board, obviously, so you have to connect with the remote operators or completely autonomous systems, so it's going to be all digital. So some things are going to be easy for advanced air mobility in the first wave, but as they start to push towards highly autonomous advanced air mobility type of aircraft, then those things will be very similar. How do we push forward? So there are some things similar, some things dissimilar. The drones have a different tolerance for weather and wind, whereas the advanced air mobility may have a higher wing loading, and so they will be able to tolerate wings. So there are some interesting subtleties, but by and large, there are few things. Access to airspace, interoperability in the airspace is common.
Well, I see we're out of time, but I want to thank all of you for not only your service here on the panel, but also the work that you're doing and helping us solve these issues, and remain optimistic that we can work together towards a common solution here. I yield back, Mr. Chairman.
Thank you, and absolutely, I agree with everything you just said. I want to thank the witnesses for their very valuable testimony and the members for your great questions. The record will remain open for 10 days for additional comments and written questions from members, and we know what we have to do to advance this new technology. It really has been stuck in a rut for far too long. So with that, this hearing is adjourned.